Okay. Good evening, everyone. Today is our fifth class. We have one more class after this, and that will be the end of our course together. So today we're going to be talking about a new unit called Uniform Circular Motion and Gravitation. This is the third unit that we'll be covering, and also our last. If you go on the College Board website, this is also their third unit in the sequence of units. So today, this unit is actually going to be really short, but we'll be using the rest of the time, for review. And also, if you guys want to learn something more, I can go in. You guys can't hear me? Okay, I'll just hold this so it's clear. Okay, did you guys miss anything I just said? No, it's good? Okay. So, I'll just go back a little. So I was saying how today's going to be our fifth class, and we have one more class after this, and that will be the end of this course. So today we'll be learning a new unit, which is also our last unit, called Uniform Circular Motion and Gravitation. This unit is pretty short, so I'll be using the rest of the time, okay, I'll be using the rest of the time for you guys to get a review, and also if you guys want to learn more. Okay, let's get started. So, there's this question on the slide, and I would like you guys to think about what the answer to this question is. And I'll be putting you guys into breakout rooms. And I would love for you guys, I'll be going to each breakout room and listen to what you guys are going to be discussing about. Okay? So the question is, what does it mean for an object to be in uniform circular motion? And note that uniform is bolded in orange, which means it's probably a very important term. So just, go, when I put you guys in breakout rooms, just discuss about what you think the answer to this question is. And if possible, come up with some examples of uniform circular motion in real day life. All right. So I'm gonna put about 5 to 6 people in a room. All right. Hi guys. This is the breakout room number 1. So some of you guys, if you don't want to turn on your camera, that's fine. Just talk or put in the chat what do you think the answer to the question is. Yeah, already I like the answer. The speed is constant, but be specific. What kind of speed are we talking about? Are we talking about like velocity, linear velocity, which means an object moving straight at a velocity of some constant, or are you talking about like a different type of trajectory? Is that speed like in a straight trajectory, or is it in some other trajectory? Yeah, the velocity is changing. Okay, I'll just go over more in the chat, but I do like your first answer, the speed is constant. You should also take note of uniform circular motion. Those 3 words can give you a lot of hints. So I'll just join the next room, and I hope to hear one of you guys participate in the main room later when I ask you guys to tell me what your answer was. Just come up with like a team answer, right? All right, so how do you guys go around the answers? Any final thoughts? Circular fashion? Yeah, definitely. Because it's called circular motion. I think it's not changing. What's not changing? Okay, try to think of real life examples. Probably that might help you. That might help you think about the different objects we might have in real day life. Wheels, yeah, that's good too. So, what kind of answers do you guys come up with? Daniel, I don't think I can see your chat because it's a breakout room chat. But yeah, but just did you guys see my announcement about the 30-second thing?
Yeah.
All right, thanks. Okay, so I would like to know if you could just raise your hand or put in the chat what kind of answers you guys came up with, or what kind of real life examples um that you think are uniform circular motion. Wow, these are really good answers. Anyone else? Anyone could think of a example? Okay, a fan, a wheel. Earth rotates the sun. That's good, right? Gravitation. Rocket ship in orbit. Exactly. That's how satellites work. Yeah, orbits. Okay, so I think most of you guys all nailed it right on the head. Um, uniform circular motion is basically an object in constant speed. However, it's moving in a circle, if you could think of it like that. So now we're going to go back to the presentation, and here's the answer. Something is moving in a circular trajectory at constant speed. Okay, it's very simple to what you guys said before too. Okay, so the main thing you have to know about gravitation is Newton's universal law of gravitation. So before we talked about how on this planet, right, the force of gravity is equal to mg, right? And where m equals the mass and g equals the gravitational field strength. Now the g that is in this picture to the left is different from the g we're talking about, which is 9.81 meters per second squared. Later, we'll actually do a derivation together, and you will see where we get the mg from. But basically, the mg comes from this equation. Sorry, F equals big G times N1 times M2 over R squared. And basically, Newton basically came up with this equation through calculus derivations. And this is how we also calculate the gravitational force between two different objects like planets, things like that. And they're used in like astrophysics and also other calculations as well. So as labeled in the diagram to the left, right, F equals the force, the gravitational force, G is the gravitational constant. Gravitational constant is just like Pokemon Mew, like the Mew we're talking about in friction. It's a constant, it doesn't change. It's just a value. M1 is the mass of a planet or object that you're talking about, and M2 is the mass of the other object. Okay, it doesn't matter which one you choose as M1, which one you choose as M2, because as you know of the commutative property in multiplication, right? It doesn't matter if you do 4 times 5 or 5 times 4, you get the same answer, right? And then the radius is on the bottom that represents as R. And be careful of the radius, what we mean as you can see in the right, the bullet points, R is a distance between the centers of the object. Be careful, it's centers, it's not the edge of the planet. But some people, when they calculation, they just take the edge from one planet to the edge of the other planet. It's really the distance between the center of that planet to the center of the other planet. So sometimes in the problems, they might tell you, okay, this planet is 1,000 meters away from this other planet. But then what you have to do to calculate R is you have to add the radius of planet 1 and the radius of planet 2 to find the actual R. All right. So looking at this equation, can you guys form any relationships or anything that you think might prove this equation? Okay, so I'll give you an example. So basically, you see like M1, M2 is on the top, right? And for fractions, if you increase the numerator, what happens to your value that you get? So let's say I have 5 over 4, and then I increase that from 5 to 6, so now I have 6 over 4. What happens to your answer? It gets bigger, exactly. So similarly, we have M1 and M2 over R squared. So if you increase M1 and G is a constant, so you can't increase that, and assuming R remains constant, what happens to your F? More, exactly. So if you could think of this, you could think of like black holes. Basically, black holes have a lot of mass. Sometimes they're indefinite, meaning they keep on increasing with no constant value, but they have a ton of mass, right? And if you have like a tiny speck of dust compared right next to the black hole, that gravitational force on that speck of dust is very huge because your mass is so big, right? Your mass is increasing and your radius is constant, so that force is also increasing. If you could think of it also, right? If you have like a slingshot, right, and you swing something in the air, right? If you increase that mass, you're having more force. You're experiencing more force, right? Compared to if you're swinging something very light. Similarly, if you decrease the radius, right, what happens to your force? So imagine you have a slingshot and I decrease the radius of that string, what do you think happens to the force that I experience? Exactly, it also increases. What if I increase the radius? What happens to F? Less, exactly. And what if I decrease the mass? What happens to the force? Exactly. Okay. So I just want you guys to understand how we get this equation, how we can conceptualize this in our real everyday life, right? Before also I talked about, I think in the beginning I talked about the Earth's gravitational field on us, right? Because the Earth's mass is so big, we feel such a big gravitational force, but the Earth itself is really not feeling anything. Like it's not really experiencing a force compared to the amount of force we are experiencing. Okay. Um, so let's do the derivation together now. Okay, so before I talked about how we got this mg equation, right? Uh, the force of gravity on Earth is equal to mg. I would like you guys to use this equation, uh, Newton's universal law of gravitation, and try to get this equation mg. Okay, I'll give you some hints. So first, I listed out all the values, right? The mass of the Earth, the radius of the Earth at sea level, the gravitational constant, big heat, right? I listed everything here. So a hint I would give you is, try to plug in these values into this equation and see what you get, and you'll actually be very surprised with the answer you get. I've done this also um, before, and it's really cool seeing where you get these equations from. Because I personally I don't like to give students random equations and be like, oh, memorize this. When you have a question with blah 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 blah, you have to use this equation. You have to use that equation. You really want to learn how you get these equations from, where you get them from, and when you should use them. All right. So when you guys are done, just put it into the chat what's your final answer. And you might, and as you can see, we have two masses, M1 and M2. It doesn't matter, you can use either M1 or M2 as the mass of the Earth, but you'll have M remaining, right? Because you can't just delete a variable. Uh, Daniel, if you don't have a calculator, you can always go on Google Calculator online. It's the same thing. Or if you're using a phone or a computer, you should also have a pre-installed calculator as well. We're not using anything fancy like sine or cosine or tangent like last time. So it's just simple multiplication and division. I don't quite, what is, okay, so basically you have this equation, right? G m1 m2 over r squared, right? I told you the mass of the Earth is listed on there, and their radius is also there, and the gravitational constant is also there. So what you would essentially do is you substitute these values into as the variable and actually solve it using the equation. But since you're missing a variable, right? I don't tell you what the other m2 is. You have to leave that as on the others, like you have to isolate the variable. um like one of the things for AP Physics is you need to know some algebra. If you really don't know how to do this, like I understand most of you are probably in a middle school or elementary school, I'll go over this later, but I would like for those who aren't like, who know basic algebra to try this out first, because I don't like giving out answers. It's really destroying the point of learning. All right. Does anyone need more time on the calculation? Just put it in the chat how much time you would need. Anyone else need more time? F is F sub g is the gravitational force. F is usually force in physics, and the subscript of F usually tells you what kind of force it is. So if I have F sub F, it's usually force of friction. If I have F sub G, it's usually the force of gravity. If I have F sub L, it's usually the force of lift. F is usually the variable for force. All right, so Daniel says he's good. Anyone else need more time? Okay, so I'm assuming all of you guys are done since none of you guys are answering the chat if you're done or not, except for a few of you. So I'm just going to get started, and hopefully you'll be done before I reach the end. So we have, let me just put it annotate. So we have Fg equals G m1 m2 over r squared. Right? No questions about that. And then we have the mass of the Earth, right? So what I was saying about substituting it into the calculator is actually saying substituting it into the equation. Okay, so all these values. So we have the gravitational field strength. I'll just denote that as 6.67 times 10 to the negative 11. The units will match out later on. I just want to make this very clear and concise. And then we have M1, which is 5.972 times 10 to the 24. Right? And then we have M2. And then the radius is square root, no, not the square root, the square of 6378.137. I did say put your units, but because the space is so small, I'm not putting the units, but for future calculations, please do so. Okay, so the top, right? You put in your calculator 6.67 times 10 to the negative 11 times 5.972 times 10 to the 24th, right? Just like so. And then we get equals 3.98, just rounded to the hundredths place, right? Times 10 to the 14th power m2, right? Because you saw this variable. And then the square of 6378.137 is 4,000, not 4,000, 406,806 point, no, 631.59. All right. So now what you would do is you take the numerator, right? You divide it by the denominator to get your coefficient. And Oh, sorry about that. I did have to convert km to meters. So for the radius of the Earth, right, it says right here, 6378.137 is kilometers, and it's actually kilometers is 1,000 meters. So I would actually have to times 637.8.137 by 1,000, and then square that. And the square root would actually be 4.068 times 10 to the 13. Okay, and when you take 3.98 times 10 to the 14th, right, and you divide it by 4.068 times 10 to the 13th, guess what you get? 9.79. And what does this number look like to you? Just put in the chat. What number do you think this really this looks like? Or what variable do you think it represents? Gravity, exactly. It looks like 9.8 meters per second squared, right? So in fact, these scientists, right, these physicists, they didn't just get these numbers from nowhere, right? It's the gravitational field strength, right? And on Earth, that is 9.81 meters per second squared. So this is 9.79. So the thing they do is they would make calculations of the FG on different parts of the Earth because the elevation, right, the height, I'm sorry, the radius from the center of the Earth to different parts of the Earth are different, right? If you're on Mount Everest, your radius would be greater than if you're on the bottom of the sea. Okay, so they would basically do these calculations, and they would do many of them and take the average, and they would get 9.81. All right, so I hope you guys all get it. If you don't understand what I just did, please put in the chat, and I would love to explain before I move on, or clarify anything you guys have any questions of. Okay, and also just to say, the reason why we get mg is because there's a m right here that we don't have a value for, so it's a variable. So this basically comes down, and this division also comes down, and that basically comes as mg, right? G is just 9.81, but that also can change depending on where you are. How did I get FG again? So, right, I started off with the universal law of gravitation, Newton's laws, right? It's also in the bottom right diagram, right? This, right? The G, I already put right here on the bottom, right? That's 6.67 times 10 to the negative 11. I'm not putting the units right now because it makes everything really confusing later. But if you want to do like a unit check, you can always do it, and it should give you the answer at the bottom as well, the units. So basically what I did was I plugged in all these values into the equation, right? You have G, that's 6.67 times 10 to the negative 11. And you also have M, the mass of the Earth, which is 5.972 times 10 to the 24th kilograms, right? And then what you would do is you times that, the mass of the Earth, by the gravitational constant, because that's what the equation tells us, right? And then you don't put anything for M2 because that depends. It's a force of gravity, right? And it depends on a object. It's relative to the mass of the object, if you could say it that as well. The bottom is the radius, right? And the radius is 6378.137 kilometers. Because it's in kilometers, you actually have to times that by 1,000, because we work in meters instead of kilometers. And then after you times that by 1,000, you would then square root, not square root, I can't say square root. You would square that value and divide the numerator by the denominator. And that fraction should give you around 9.8. And that 9.8 is exactly what Daniel and the Mies user said as gravity on Earth, right? It's not, you guys shouldn't really say just gravity, it should be gravitational field strength, all right? Do you guys understand it now? Or do you guys still need me to repeat something or clarify something? The units, okay, the units would be, since it's a gravitational field strength, it would be meters per second squared, right? 9.8 meters per second squared. And the mass would be in kilograms. Okay, the unit check is a little more complex because you also have, like for the gravitational constant, you have like m3, kg, -1, s -2, and to this -2 power. So some of you guys haven't learned about negative exponents yet. But if you would like, I would probably stay at the end of the video, of this class to do a unit check if you guys really wanted to see how you get meters per second squared. Okay, so most of you guys are saying you're good, you got it. Okay, so let's move on. So you're officially now done with the first 3 units, right? As I said, gravitation and circular motion is really quick. When we say uniform circular motion, we're talking usually referring to orbits, gravitation, things like that, because we don't really see uniform circular motion in everyday life. You might imagine, or you might be a very creative person and think of examples, but in calculations, you would find out that most of them are not uniform circular motion. Okay, most of them are gravitation, and that's why we usually refer uniform circular motion with gravitation. So they go hand in hand. So now, since you guys are officially done, right, and we still have 2 classes, we're not just going to do nothing. You have 2 options. So the first option is we could review previous units, right, kinematics and dynamics, or if you want to review gravitation again, that's fine. And we could do some practice questions because some of you guys, we never had time to do practice together. Some of you guys did have time to stay a little late to do that, but most of you guys didn't. We could do some redo Kahoots because the last Kahoot we did, 38% of the questions were answered correct. So that's not a very promising number. And also, if you have any questions, right, if I wasn't able to answer them, that would also be a really good time for you guys to ask. The second option you can have is we can learn about centripetal motion and learn more in depth into rotational motion, like rotational kinematics, things like that. That is more complex. It's also following the AP Physics 1 curriculum, so it goes more in deeper. Okay, I see a lot of option 2. Daniel is spamming 2 in the chat. Okay, I see a lot of you guys are putting option 2. All right. But before I move on to option 2, do you guys feel like you're really like set on with all the topics we learned so far, like kinematics, dynamics, and circular motion? Like you're spot on, you know everything, and you're really firm in that foundation. Because if I move on to centripetal motion, it's going to be building off kinematics and dynamics, things like that, except it's going to be in rotational form. So instead of being in linear form, which is straight, it's going to be like circular, things like that. It's going to get a little messy. So I want to make sure that all of you guys are really firm in the basics before we move on. Okay, I see we could review on dynamics a bit more. Some of you guys saying you're good at it, but not everything. It would be really good if you could specify what you think you might need a little trouble for, because what I could possibly do is use like 10 or 5 minutes to go back on a certain unit that you guys are really confused on, and then we move back into centripetal. So right now I'm getting dynamics. Which part of dynamics are you not understanding? Okay, applications and problems. Okay, we could probably do a practice problem or application or how to solve them. Class is not over today, so we also have one more class together. That class will be, if you guys want to do Kahoot, we could do that again, or we could continue on to Centripetal. And I also have a lot of important stuff to talk to you about on the last class, because I might do a continuation of this course. It just probably won't be on Wave, because like I started a nonprofit for myself, and I've done that last year. And we're also in the last class, I mean, in the continuation of this course, we might doing something a little different from like slides, things like that. We might be building things. So it's going to be a little different, but it'd be like a continuation. So you should come back to the last class if possible, because I have a lot of updates to talk to you guys about. Okay, I see just dynamics. You guys are just, I see Rachel just said dynamics a little bit more and its applications and problems. So I think I'll just go back in dynamics really quick, and then we'll go back to centripetal. Is that fine with you guys? Yep, okay. Okay, so Rachel said that she wanted to do some like review on applications and problems. Anyone else have any concerns or would like to request something? Okay, so for the practice, this is a practice question that I did last time with two students who stayed late afterwards. Um, so I'll just be showing you guys really quick about how to do this. If possible, I would really recommend you guys to do it on your own as well, like follow along, because while I'm talking, it's also really important that you guys are practicing. So it's really getting into your brain. So it's not like going one ear and coming out the other. Um, Okay, so just give me one sec. Just read the problem and um, think about how you would approach this problem. Okay, so the question says an airboat with a mass of 3.5 times 10 to the second kilogram, including the passenger, has an engine that produces a net horizontal force of 7.7 times 10 to the second power newtons, right? After accounting for forces of resistance. So the way I would approach this problem is write out my givens, right? Uh, write out everything that I know the problem is giving me and find out what variable am I trying to find, all right? So it tells me that, sorry. Okay, so it tells me that the mass is equal to 3.5, I'll just say 3,500, right? Kilograms. And then the net horizontal force, right? It says net horizontal force, which means that it's the sum of all the forces. So the net force is equal to 7.7, or you could just say 7,700 newtons. Okay? For part A, they're asking find the acceleration of the airboat. So your acceleration is the problem you're trying to find. Okay. So using Newton's second law, or knowing what you know about dynamics, what equation do you think, or which law do you think you could use to solve this problem? Okay, I see a second law. What else? Yeah, F equals ma. Oh, and by the way, this problem is from a college textbook. So if you guys have are having trouble like solving it, it's no big deal because it is a college problem. If you guys are thinking this is really easy, that means you're on a good track. All right. So I see a lot of people saying net force equals ma, and that is correct, right? It literally tells us a net horizontal force of 7.7 times 10 to second power newtons, right? So what would you do now, right? You got your equation. You know that you're using uh, you know that you're doing F equals ma, right? And you know your mass, you know your newtons. What would you do now with this equation? Okay, I see 7,700 divided by. Okay, yeah, F over m, right? You isolate the variable that gives you a. So what would your answer be? Units. Think about the units. I see a 2.2, but it's technically wrong right now because it doesn't have units. So what units should be behind 2.2? Yeah, exactly. Meters per second squared. All right. Always don't forget your units. They're really important. Okay. So now that we know, oh my goodness. So now that we know that the acceleration is 2.2 meters per second squared, right? Um, I can basically say acceleration equals 2.2 meters per second squared. Oh my goodness. Sorry about that. Let me just rewrite it. Equals 3500 and the acceleration is 2.2 meters per second squared. Okay, so now we find the acceleration. We move on to part B. Starting from rest, how long does it take the airboat to reach a speed of 12 meters per second? Okay, so when it says starting from rest, it's basically saying that this object is in static equilibrium, which means that this object is not moving. It may or may not have acceleration, but it is not moving, right? It's starting from rest. So that means that its initial velocity equals 0. Okay? You guys all agree with that? When it's something starting from rest, its initial velocity equals 0? Okay, so initial velocity equals 0 meters per second. Okay? Now, it says that it reaches a speed of 12 meters per second, which means that the final velocity is what? Put in the chat, what do you think is the final velocity? 12 meters per second. Yeah, exactly. Okay, now it's asking you, how long does it take the airboat to reach a speed of 12 meters per second? So what is the variable they want you to find? What is the variable? Seconds, right? It's saying how long. How long is it something going to take? It's not asking about acceleration, though it can be related to acceleration, but the answer they're trying to find is time in seconds. All right. So now we could say time, right, equals the question mark. It's what we're trying to find. So the thing about AP Physics one is that no problem I've ever practiced or encountered is ever about one topic itself, right? It's always like units interconnected. They put like energy, momentum, and rotational motion. They stuff all of that into one problem, right? They could give you a problem where you have a block and it's on a hill. It comes down and there's like a ramp and then it flies off, and they ask you, oh, what's the time it takes for this object to hit the ground? So it's really complex. You would have to do like an energy analysis, and after it turns into a projectile, you have to convert that into a projectile motion problem. So learning about dynamics, kinematics, and uniform circular motion, how do you think you would solve this problem? And in the hint I just said before, this problem is going to be not only about dynamics, it's going to be like kinematics, other units involved as well. What kind of, what are your thoughts about solving this problem? Any guesses? What would you use to solve this problem using what we have learned before? Okay, so we use the kinematic equations, all right? The reason why is because it literally says how, like, it says they give you the initial velocity, tell you the final velocity, and, sorry, velocity. Right, they tell you the initial velocity, they tell you the final velocity, and you just solve for the acceleration. So you know your acceleration, your initial velocity, and your final velocity. You can use a kinematic equation, right? Why not? And you can find the time for it. So I'm hoping many of you guys probably memorized the equations by now, or you have some idea of how they look like. Sorry, my computer just glitched again. But yeah, okay, you would use the equation VF equals V naught plus AT, all right? The reason why you would do this is because the other equations are VF, I believe, delta X equals V naught T plus 1/2 AT squared. And the second one is VF squared equals V naught squared plus 2A delta X. So you have delta X in the first and second equations, and you wouldn't use that because they don't tell you the time, they don't tell you any distance whatsoever, and they're not asking about the distance. So immediately you can eliminate those two equations and use the third one, right? Because it has all the givens and you can just solve for one variable. So meanwhile, my computer is not working. Try to make this calculation on your own using the equation I just said, VF equals V naught plus AT. And try to solve for time. Can you guys hear me? Or anyone putting in the chat anything? Okay. Do you guys need help, or you think you might take a stab at this question? Help. All right. I'm gonna try my best because my computer is kind of lagging right now. But okay. Okay, so before I talked about using a kinematic equation, right? We have VF equals V naught plus AT. Yeah, Rachel, I think you got it. Brian Way also, I think you guys got it. It is 5.45 seconds. Okay. Basically, for you guys, for those who don't understand how they got 5.45 seconds, you get your initial velocity, right? That's 0, so you can cancel that out. Final is 12 meters per second, right? You just solve for acceleration, right? So you just divide both sides by acceleration. Your acceleration equals 2.2 meters per second squared, right? So 12 divided by 2.2 gives you 5.45 seconds. All right, you guys all got that? That's how they got it from. So the third question is, let me just go back to the share screen. The third question is, after reaching that speed, the pilot turns off the engine and drifts to a stop over a distance of 50 meters. Okay, find the resistance force, assuming it's constant. So after the pilot turns off the engine itself is not producing any force, right? Because the engine is powered off, right? So the only force is your resistance force, right? And it says it drifts over a distance of 50 meters. Okay, so so they give you a distance, but they want to find a force. So you definitely know that this is a kinematic with dynamic problem, right? Because forces deal with dynamics, right? Kinematics don't do that. And distance is related to kinematics because it's seen in the kinematic equation, right? But dynamics doesn't deal with that. Dynamics just has F equals ma. It doesn't have a delta x or something, right? So you immediately should know that this is a dynamic and kinematic problem, right? They're combining things together. So you would either have to find something in kinematics first and then substitute that into dynamics, or you would have to do it in dynamics first and substitute that into kinematics. So, okay, let me just write this out. So we know that the kinematic equations are Vf equals V naught plus At, right? And we also know delta x equals V naught T plus 1/2 AT squared. And we also know that Vf squared equals V naught squared plus 2a delta x. Okay, and in dynamics, we know that we only know this, F equals ma. The net force actually is equal to ma. So looking at these equations, right, you got the kinematics here, and you got just your Newton's law right here, right? Which variable do you think you can substitute in either equation? So meaning you can find that variable in one equation and substitute that into the other side equation, like a dynamic equation. Which variable? Right? We have the variable Vf, we also have the variable V naught, we also have the variable T, and we also have the variable acceleration, and we also have the variable delta x. On the Newton side, we have F variable, right? We also have the variable M, and we have the variable A. I'll give you a hint. Find the variable that you see on both sides. Acceleration, right? So the reason why I was talking about like kinematic dynamic problems is usually they deal with acceleration, right? They give you problems and they give you givens that you can only solve for in one side, and after you find that acceleration or the variable that you want to find, then you will substitute that into another equation. It can be either dynamics, it could be energy, it could be momentum, it can be other units as well. Okay, so that's a key concept. Try to think of that. Okay, no problem is ever just one unit alone. Okay, so let's just go back to our problem, and they say an airboat. Sorry, after reaching that speed, the pilot turns off the engine just to stop over a distance of 50 meters. So we know that we have to find for acceleration now, right? Because we're linking kinematics and dynamics, and the only way we could do that is through acceleration because it appears in both equations. So they give us a given first, and it's 50 meters. So do you think we should start off with dynamics, or do you think we should start off with kinematics? They're asking for resistance force, and they give us 50 meters. So they tell us it's 50. Okay, I'm assuming that's kinematics. Okay, if you said kinematics, that is correct. The reason why I'll just explain it really quick is because they give us 50 meters, right? 50 meters is a unit for delta x, right? It doesn't appear in mass, acceleration, or force, right? Because those aren't the units for those variables. And they ask us for resistance force, and resistance force is only something in dynamics. So they give us something in kinematics, and we are asked to find dynamics. That's why we solve from kinematics and then we go to dynamics. All right. So if we use kinematics, which kinematic equation we should use first? So let's go back to the whiteboard, and which equation do you think we should use to solve for acceleration? This is 1, 2, and 3. Okay, I'll just write on the side, right? They tell us VF. We already solved for VF, right? They tell us VI, right? We also solve for acceleration. They also tell us delta X. Actually, no, they don't tell us acceleration. We're trying to find acceleration. Which equation do you guys think we should use? Equation 2. That's a good guess, but I think there's a simpler way to find this. 3, okay. Any other guesses? Okay. The correct equation is equation 3. I'll explain it right now. The reason why is because they don't give us a time given, right? They don't tell us, oh, this object has 5 seconds before it slows down, right? It doesn't say that. It also doesn't ask us about time, right? We're only trying to find acceleration. Exactly. A is the only unknown in the equation, right? If you have A and T, you don't know what T is, and you don't know what A is, it's going to make it really hard for you to solve for either variable, right? And the reason why you would just eliminate number 1 is because they don't have delta X, right? The problem gives you delta X, but this equation doesn't have delta X, so you don't have to use it. Number 2 is because there's time in here, right? You don't need to find time, and you don't even need to know about time because it's not related in this problem. So the only equation you have left is equation 3, right? They tell you the initial velocity, they tell you the final velocity, and they also tell you delta X, which is 15 meters, and they just want you to find acceleration. So I always find for one unknown. If you have one unknown, that's the equation you need to use. Okay, so using this equation, now find acceleration. The way I usually like to solve kinematic equations is not substituting the numbers first, but solving it algebraically. So basically, use this equation, isolate the variable a, and then plug in the numbers. Okay, the reason why I do this is because in more complex calculations, when you plug in numbers, it's really hard. You have like a bunch of things going on, and you can't. You're just be like, oh, where did this number come from, and things like that. Okay, so I'll just show you real quick. Right, we have this equation. Let's just bring this all the way down here, and we have VF squared minus V naught squared equals 2a delta x. Right. And the way we would get a is divide both sides by 2 delta x. And this would give you the equation for acceleration. So solve for acceleration really quick now before you guys leave to other classes. Oh yeah, and right now is 3 o'clock, so I understand if you guys have to go, it's fine. But for those who want to, solve the problem, you're welcome to stay as well. So now you guys are officially dismissed. For those who want to stay, you can stay. For those who don't want to, you don't have to. Oh yeah, and please come back to the last class because I do have some updates to give, and I will be also talking a little more about centripetal motion. Ali, what do you think you don't understand? 1.44. Be careful. Is it negative 1.44 or positive 1.44? And what are the units as well? Okay, so note that this is one thing and this is one thing. Don't confuse the exponents with something else. They're two separate entities. Arrow, you're close. You got 1.44. It's just if you mess up the signs, that can be a really far answer. Any other guesses? Okay, I'm just gonna carry this on really quick because I know some of you guys have to go places. It's negative 1.44 meters per second squared. Ariel, if you mess up a calculate, I think you just probably messed up like a calculation, a simple calculation error. So you can just go back and check. You should be getting negative 1.44 meters per second squared. Okay, so now after you found acceleration, and we link kinematics to dynamics using acceleration, and they ask you to find the force. So now, using your acceleration, what would you do to find the force? Think about Newton's second law, right? When we refer to dynamics, we just know net force equals ma. That's literally the only equation we have. And we just found acceleration, and they're finding for force. So what do we do to get that force? Not 5040. You're close. 50. I mean, your first three digits are pretty close. It's just try to go back and see what kind of calculation you made wrong. Anyone else need help? If you're totally stuck, that's fine. You just put in the chat and let me know. I'm more than happy to, go over any parts you got confused on. Would you guys like me to go over the problem, like actually solve it with you guys? Do you think that'll help? Or do you think you could handle this problem? You just need a couple more minutes. Could you guys like answer, please, the question? It's really awkward when I'm talking to like mid space. Jason, Zhao, Jian, Jordan, Timmy Wu, Umbrian. Anyone have any questions? Yeah, Ariel, you got it. Though you might want to change your acceleration, the 1.44. But I'm assuming if you get the right answer at the end, you probably fixed it already. So yeah, you got it. I think I'll just cover centripetal motion and go more in depth next class, because I feel like some of you guys still have some trouble with kinematics and dynamics. And the reason why I don't want to go so fast is because it's really important to get a good foundation, because if you don't know dynamics and kinematics right now, you're most likely going to screw up when we turn it into rotational rotational form. Just think of centripetal motion as a rotational form of all this. So instead of having like a linear velocity, you have like angular velocity. And instead of having acceleration, you have angular acceleration. You know, things like that. All right. And then instead of having force, you have torque. Okay. Timmy, Wu, Jordan, Jiang, Jason, anyone have questions? Ariel, do you have any questions? If not, I'm probably just going to close the meeting here. The final answer is negative 504 newtons as the resistance force. Sorry, didn't mean to send that as private. Okay, so if you guys don't have any questions, I will close the meeting. If you guys don't have any questions, I'll just wait like 20 seconds.